Hello students, I am Dr. Nimi Singh. Today I bring you a learning module which is Firearm and its part 3, in which we will discuss about improvised firearms and principle of examination. We will also discuss about identification of bullets, wads and pellets for improvised firearms. We will wind up this module with a case study. Let us start our module with a look at what we are going to learn today. The first thing is going to be the introduction of the topic, principle of examination, identification of bullet, and under that comparison microscope in identification, examination of bullets, comparison of question bullet and sample bullet, identification of wads, wad distribution, identification of pellets, pellet patterns, and in the end conclusion. The improvised firearms, which are also known as country-made firearms, homemade firearms, pipe guns, zip guns, etc. Now, these firearms are made by the ordinary blacksmiths having no particular specifications, neither any standard raw material is used. Now, these weapons have very short span of life and most of them are extremely dangerous. Now, the word improvised indicates the nature of firearms. It is more appropriate to refer to this class of firearms as improvised firearms rather than dubbing them as country-made firearm, etc. However, the name country-made and improvised are being used in this country very frequently. Now, both the names are being used in this discussion without any distinction. The country-made firearms are actually improvised by the culprits from readily available materials, either personally or with the help of a local blacksmith. Now, the demand for the improvised firearms has increased so much in recent times that there is considerable demand for these weapons in Uttar Pradesh, Bihar and in some other border states, and the demand is increasing day by day. They are often manufactured to fire the ammunition which the culprit gets easily, either from the illegal market or from his friends. The simplest improvised firearm which has been used in a criminal case was an iron tube in which 0.22 cartridge could be fixed. The firing was done simply by hammering the head of the cartridge. The advent of the country-made firearms is the result of the stringent controls on the manufacture and sale of ammunition and also of the licensing policy of police for the firearms. No person in India can get a firearm license and keep a gun unless his name is cleared by the policy after the verification of his antecedents. Likewise, the ammunition can be purchased only by a firearm license holder, the quantity of which is limited by an insertion in the firearm license itself. The culprits who need firearms and ammunition tap the clandestine markets or they go in for the improvisations. The trade in improvised firearm in India has also been promoted by the fact that the cost of the firearm, especially of handguns, is very high. The normal criminal cannot obviously afford it. Hence, the trade goes on flourishing. The country-made firearms, as already seen, are the non-standard firearms. They are not tested or proved for their fireworthiness. The weapons, therefore, are usually imperfect contrivances which are highly dangerous even to those who use them. Besides, they are also not amenable to the standard techniques used for evaluating the forensic ballistic problems generated by them. The evaluation of the evidentiary clues in the improvised firearm follows the usual pattern for correspondence clues in the standard firearm and ammunitions. The parts of a firearm which come in contact with the cartridge or bullet are firing pin, the breech face, the extractor, the ejector, the chamber and the barrel. They are made of steel by cutting, hammering, filing, re-aiming and polishing. The tools used in their manufacture are applied at random. The cutting surface of the tools used continue to change because of wear and tear they suffer due to their action on steel. The finished surface of the relevant portions of all firearms is therefore never alike, even when the two surfaces are made with the same set of tools one after the other. Consequently, all firearms possess an individuality of their own. This has been established by actual experiments carried out in the initial stages of the development of this science. A long barrel was bored and grooved with the same set of tools. It was then cut into 6 pieces and fitted to 6 firearms. The bullets fired through the 6th barrel of those 6 firearms were correctly identified in respect of the individual barrels of the 6 firearms. The peculiarities of the surface of a firearm are enhanced with the use of the firearm because of wear and tear and accidental damage. When a cartridge is fired, the irregularities of the surface imprint their pattern on the case or the bullet because of close contact under pressure. These patterns are also called thumbprint of the firearm and permit their individualization. The cartridge cases and bullets are usually made up of comparatively softer metal than the material used in the manufacturing of the firearm. The marks produced on surfaces therefore do not change substantially for thousands of shots, and the fired ammunition can be identified easily even when the firearm is recovered after a long interval. If the firearm is ill kept, misused or intentionally tampered with, then the surface may change. The extent of variations will depend on the changes so made. The fired ammunition may or may not then be identifiable. Each case has to be decided by actual experiments. For example, in a murder case, the firearm was buried underground for many months. It was possible to identify the fired bullet only after it had been carefully cleaned and in spite of the fact that the firearm had rusted extensively from outside. Sometimes very old firearm is used in the commission of crime. Due to extended use over long periods, the barrel of the firearm gets washed and its bore becomes larger. A bullet fired through such a firearm does not house properly in the barrel, and hence it is not imprinted with identification marks, that is the thumbprint of the firearm. Generally, this does not happen during the interval between the occurrence of the crime and recovery of the firearm. Some criminals use previously fired bullets in cartridges of higher caliber. For example, 0.325 bullet is placed in a 12-bore cartridge and fired. Now, this misleads the investigating officer. He searches for a rifled firearm rather than a shotgun. It further complicates the investigation. Now, if a cartridge of lower caliber is fired through a firearm of a higher caliber, its bullet does not fit in the barrel and often does not take identifiable marks. If some marks are however discovered on the bullet, they are compared with the fired test bullet of the same caliber as the firearm. In some cases, it gives indeed a useful match. Sometimes a loose bullet is marked imperfectly and the test bullet of the right caliber does not give correct match. Now, in such cases, a lead bullet or a slug which is specially prepared of slightly larger diameter than the bore is pushed through the barrel. It takes up most of the marks from the barrel and provides useful test material. Now, bullets fired through rifled firearms, they receive both the class as well as accidental characteristics of the barrel from which they are fired. The bullet will show not only the primary markings left by the lands and grooves of the gun barrel, but will also reveal fine striations in all the marks. These are the imprint of the small irregularities in the barrel and are never duplicated by different weapons. To determine now whether or not a particular firearm has fired the question bullet, a detailed comparison is made of markings on the question bullet with the corresponding markings on the test bullet fired from the suspected firearm. A bullet comparison microscope is then used for such a determination. The suspect bullet and the test fired bullet are illuminated obliquely in order to create shadows that reveal the ridges and furrows engraved by the firearm. Now, comparison microscope in identification and its use. Now, comparison microscope is probably the most important and the most widely used scientific instrument in a modern crime laboratory. The first comparison microscope to be used in the field of criminology was a very crude instrument compared to highly developed instruments now available. It was designed by Albert S. Osborne for application in the field of document examination. A comparison microscope consists of two compound microscopes having identical optical systems so that they give the same magnification connected by an optical bridge containing combination of prisms such that by viewing two separate objects, one under each microscope, through a single eyepiece, the two objects may be compared by bringing the images of parts of each into juxtaposition. The optical field seen through the single eyepiece is a circular area divided into two parts by a thin dark line. The object under the left hand microscope, say the evidence bullet, is seen in the left half of this optical field, and the object under the right hand microscope, say a test bullet, is seen only in the right half of the field. Now, let us come to the examination of bullets. A bullet is a projectile fired from a rifle weapon and is a part of rifled cartridge. The bullet, while passing through the barrel, gets the following characteristic of the barrel. First is the class characteristic mark of the barrel, and second, accidental characteristic marks or individual characteristic marks. Now, let us come to the class characteristics. Now, the number, the width, the depth, the direction, angle and pitch of lands and grooves on a fired bullet indicate the class characteristics of a firearm and would be common on bullets fired from firearms of the same make and model, but would be different in respect of different makes and models. Class characteristics are useful to the extent of quick eliminations only. Now, let us come to individual characteristics. Now, finer details in the lands and grooves are the individual characteristics of the firearm. Individual features are helpful as they are always different and no two firearms have the same characteristics. These characteristics are useful in comparison of bullets. Individual characteristics are the imprint of the small irregularities in the barrel and are never duplicated by different weapons. Comparison of the question bullet and the sample bullet now. While questioned bullet may be found at the scene of crime or removed by doctor from the dead body of the victim, the sample bullet or the standard bullet need to be obtained from the recovered weapon. There are various methods for recovery of fire bullets, and one of that is firing the bullet in a water tank and its recovery from the tank. In India, most of the forensic organizations use bullet recovery box for recovering the fired bullet, which is the standard bullet. In shotgun ammunition, there are a number of wads and comprises of overpowder wad, air cushion wad, undershot wad and overshot wad. They keep the powder charge in the cartridge in their proper place. In addition, the cushion wads, they seal the barrel on the firing and thus prevent escape of gases and consequent loss of velocity. They also clean and lubricate the barrels. Overpowder, undershot and overshot wads are made of special quality cardboard varying in thickness from about 2 to 3.5 millimeter. They are waterproof. They are slightly larger than the bore of the firearm for which they are intended. Wad diameters of various shotgun ammunition. Let us first come to the bore 10. Now, bore diameter is 0.775 in inches and in millimeters it is 19.7, while wad diameter for the same is 0.784 inches and 19.9 millimeter respectively. For 12, bore diameter in inches is 0.729 and in millimeters is 18.5 millimeter, and wad diameter for the same is 0.738 in inches and 18.7 millimeter respectively. For 16, bore 16, the bore diameter is 0.662 in inches and 16.8 in millimeters, while wad diameter for the same is 0.67 inches and 17 millimeter in diameter respectively. For 20, the bore diameter is 0.615 inches and 15.6 millimeter, while wad diameter is 0.623 inches and 15.8 millimeter respectively. For 24, it is 0.550 in inches and 14 millimeter in diameter, while wad diameter is 0.557 inches and 14.1 millimeter respectively. Cushion wads are made from felt, cork, feltine, that is shredded paper, cardboard and plastics with air holes. They seal the barrel properly and prevent escape of any gases. The cushion wads are about 12.5 millimeter thick and are often greased. The grease lubricates the barrels. The modern shotgun wadding has undergone several changes in the last few decades. The following changes have been made. The base wad is plastic mold and fixed in the base of the brass head under pressure. The overpowder wad has changed to an inverted cup wad open side towards and over the powder, so that when the gases are formed, the lip, the open round edge of the cup is pressed with pressure against the barrel and thus it seals the bore. It prevents the escape of gases from the sides. The cushion wad's function is carried out by the cup wad and piston, which is attached to the rectangular projectile sleeve containing and protecting the projectiles from coming in contact with the barrel and consequent damage. The sleeve has cuts along the edges in its frontal part. The four sides of the sleeve open up and fan out along the cuts. When the sleeve comes out of the muzzle, the sleeve gets separated from the projectile charge. The sleeve being lighter falls down. It does not interfere with the shots in their flights. The buckshot in a cartridge has spaces which are filled with granular plastic material to cushion them. The plastic granular material prevents damage and provides uniform push to the projectiles. They ensure proper push to the projectiles, gives better spread and uniform velocities to the buckshots. The above innovations have improved the aim, range and ballistics of the shotgun cartridge considerably well. Now, Wad distribution. Wads are found in shotgun ammunitions. They are projected along with powder charge. They enter the target of up to a range of about 3 meters. If they are not obstructed, they scatter from 5 meters to about 10 meters or more. If the distance between the victim and the wads is known, then the range of firearm can be easily determined. A more accurate estimation of range can be made by test firing with the suspected firearm and similar ammunition. The weather conditions indeed have an important effect upon the scattering of wads. They may be not blown far away or retained near, depending upon the direction and velocity of the wind at or immediately after the time of firing. The weather should therefore be taken into account for the determination of the range of fire from Wad distribution. The cushion wad, being heavier, goes to a much longer range. Formerly, the identification of buckshot and pellets fired through a smooth bore firearm was considered impossible. It appeared that buckshots packed between the wads in a cartridge are pushed through the barrel without any appreciable sideway or turning motion. The buckshot and pellets on the periphery scratch against a segment of the inner surface of the barrel. They take up the marks from these segments corresponding to a land in the rifle barrel like bullet. The marks have been found consistent to a given segment of a barrel. Test marks are obtained on a specially prepared slug which fits in tightly in the barrel. When it is pushed through the barrel without turning motion or fired, it takes up marks from the whole internal surface of the barrel. The comparison of the marks on buckshot or pellets with the marks on the slug is then carried out with a comparison microscope like a bullet. Buckshots and pellets are sometimes housed in a sleeve placed in a cartridge. The sleeve actually protects the pellets or buckshots against scrapping in the barrel. Such buckshots or pellets will not take up the barrel marks. Coming to the pellet patterns. The area covered by pellets fired from a shotgun is proportional to the distance between the muzzle of the firearm and the target. Greater the range, greater is the area covered. The spread is affected by the length of the barrel of the firearm, the muzzle of the firearm, whether choked or not, and the condition of the ammunition. If test experiments are performed with the suspected firearm and if the ammunition of the same make and batch is used, the pellet patterns provide a very fair estimate of the range. Generally, in a standard shotgun, the whole charge enters the body and mass up to a range of about 2 meters, forming a rat hole varying in diameter from about 2 centimeters to about 6 centimeters, depending mainly upon the distance between the muzzle and the target, the construction, that is a choke of the muzzle, and the size of the pellet charge. There is a rat hole surrounded by individual holes from about 2 meters to 7 meters. In buckshot charge, the individual shot may form its separate hole from a range of 3 to 4 meters. The separation of the holes is usually complete from about 10 meters onwards, especially in a buckshot charge. The spread of pellets at various ranges with different degrees of chokes is shown on your screen for a rough estimation. Let us come to the range in meters and the spread circle diameter in centimeters. Now, if the range is 10, then true cylinder, the circle diameter for true cylinder will be 54 centimeters, improved cylinder will be 38 centimeters, half choke 31 centimeters and full choke 23 centimeters. For a range of 15 meters, if the spread circle diameter is 71 centimeters, then it is for the true cylinder. For an improved cylinder, 55 centimeter. For half choke, 44 centimeters and for full choke, 66 centimeters. For 20 meters of range, 88 centimeter circle diameter will be for a true cylinder. For an improved cylinder, 89 centimeters. For half choke, 58 centimeters. For full choke, 45 centimeters. For 25 meters of range, for true cylinder, the circle diameter will be 105 centimeters. For improved cylinder, 89. For half choke, 73 centimeters and full choke, 59 centimeters. For a 30 meters range, the circle diameter will be 122 centimeters for a true cylinder, 106 centimeters for improved cylinder, 90 centimeters for half choke and 75 centimeters for a full choke. Lastly, for a range of 35 meters, the spread circle diameter for a true cylinder will be 140 centimeters, for an improved cylinder will be 124 centimeters, for half choke 108 centimeters and for full choke 94 centimeters. Now, this table is not applicable to improvised pistols and guns made illegally by the local blacksmiths which do not conform to specifications. The barrels are either too loose or too tight. The length of barrel is often short. The inner surface is rough. Consequently, the spread of pellet is not only different from standard firearm, but it varies in the same firearm from one shot to another. And these firearms do not lend themselves to reliable range determinations. For standard firearm with half choke, a rough idea of the range is obtained from the fact that every meter of distance is equal to 3 centimeters of dispersion. Mathematically, D is equal to 3R, where R is the range in meters and D is the diameter of dispersion in centimeters. Improvised firearms are manufactured without any specification and also no raw material is used. Hence, this non-standardization creates a problem when comparison of the firearm has to be carried out. In addition to it, comparison of bullet and cartridge cases is carried out with the help of a comparison microscope. In case of shotguns, pellets are identified with the help of scratch markings if at all any is present.